All right, this is part 2 of problem 13. And in this particular case, as you can see, the mirror is convex. The magnification is given by the equation m equals minus q over p, the image distance over the object distance. Negative of that equals, in this case, 0.5. We'll be using that in a bit. We also know that the distance between the object and the image is still 0.6. Since this is, we're calling to the left positive in a kind of strange convention, but we're doing that because this is the positive side of the mirror, and this is the negative side of the mirror. We say P, this distance here, minus this negative distance here, equals 0.6. So if you want to rearrange that equation a little bit, we say P equals 0.6 plus Q. We then take the magnification equation here down to here and we plug in P equals 0.6 minus plus Q on the bottom. So the magnification 0.5 equals minus Q over 0.6 plus Q. Rearranging that, you get minus Q equals 0.3 plus Q times 0.5, because you take this bottom piece over here and multiply by 0.5. Half of 0.6 is 0.3, and half of Q is 0.5 times Q. You can then compress minus Q over here, and Q times 0.5 here. So say minus Q minus Q 0.5, that equals minus 3/2 Q. So you've just brought this over to this side. So minus 3/2 Q equals 0.3. Q equals minus 0.6 over 3, then rearranging these variables here, and that equals minus 0.2. So Q is 0.2 meters on this side of the mirror. So we now know P, which is 0.6 plus a negative 0.2 or 0.4, and we know Q, obviously it's minus 0.2. So we can use the focal equation, 1 over F equals 1 over P plus 1 over Q. So that's 1 over 0.4, and it's 1 over a negative 0.2, and that becomes 1 over 0.4 minus 1 over 0.2. Getting common denominators here. You have 1 over 0.4 minus 2 over 0.4, and that equals negative 0.4. So the focal length of this mirror is minus 0.4 meters, and that makes sense because the focal length is on this side of the mirror as well. And the geometry all looks like it works out. If you draw your object here, you get your image here about halfway to the focus, which is, the focus is 0.4, that's around 0.2, and that is what we had for the object, or the image distance. The lines all converge at that image, so you know it's about half the height of this arrow, which looks about right. So it seems like we did a pretty good job here.